Okay guys, I'm really excited today. We've got a really special project where we're retrofitting a volume house build to passive house principles. I haven't heard of anything being done like this in Australia, so this is going to be great. Let's go talk to the guys about it. So here we are in a volume house building home, which we're going to be converting to passive house principles. Dale and Raf.
How you going, John?
How are you?
Good to see you again, mate.
Good to see you too.
This is Raf, the owner.
Yes.
Yeah, so 15-year-old volume builder house. The goal here is to transform it into Retrofit standard passive house. So basically, gonna start by gutting we're gonna start by taking the existing roof off. It's currently roof tiles, wrap all the roof, re-batten all the roof, seal the roof from a weather type perspective from the outside, and then re-roof with Colorbond steel. From there we're gonna move inside, we're gonna gut the whole inside, take all the plaster out. We've got a brick veneer frame here, brick veneer construction. We're gonna re-insulate all the exterior walls, all the ceiling, and then we're gonna put an air tightness layer through.
On the inside?
On the inside of the frame, yeah. Then batten off, standard form, create a surfaces cavity, and then plaster will go back on. Taking all the windows out, obviously. Yes. The old aluminium single glazed windows aren't really cutting it, so pull all those out, change them over for timber aluminium triple glazed windows. Got quite a big window schedule here, there's quite a lot of glass, and Raf really feels it. Raf and Chantal really feel it in the winter.
Basically what's outside is inside in terms of temperature, and in winter, condensation everywhere. So mold's a concern.
Yeah. So is that your main driver, Raf? Your main driver for doing this retrofit?
Well, yeah, from a healthy building point of view. So we want the energy, passive house, the quality of passive house, but the healthy building point of view is also a big part of it.
Yeah, we didn't really say at the beginning, but Raf's a building biologist.
Wow.
So Equilibria.
Yeah, so
is
study very much what makes people sick in buildings. So when it's leaky, when there's mold, when there's the insulation we're going to see in the ceiling and
high CO2 levels,
causes all sorts of health issues. So we're addressing the energy side, the comfort side through the energy side, and the health side. So hopefully we can get it all done.
Yeah. So basically it comes down to what passive house is all about.
Yeah.
Top quality indoor air, thermal performance, really comfortable day in, day out, year round. Obviously reducing energy consumption. Overall general good thing for the environment.
So we've just done an initial blower door test of this volume house building home, and it's come out to under 10.
Yeah,
ACH,
which is actually kind of surprising.
It's
tighter than we thought it would be.
But that is still quite a leaky home, but to the current building codes, it would potentially pass.
That's a bit worrying in itself.
What would you generally expect from I guess it varies a lot from a volume built house.
It can vary a lot. Some of the older homes can get like crazy leaky, and they can go towards 40 ACH or a permeability rate of 40 as well. A lot of the newer stock volume house building homes, they seem to get below 10 quite comfortably. It can depend on internal cavity sliders, evaporative cooling, ducted heating, connectivity to the return. There can be a couple of major issues with the building envelope that would just get that over the 10 permeability rate, which is what we want to try and avoid. But I think trying to get that leakage rate as low as possible is where we all need to be heading, and then complementing it with good passive house principles to try and get these homes performing healthier and more efficiently.
Continuous thermal envelope and really good quality windows and doors, really. I mean, in a house like this where you've got quite a lot of glass, the ratio is pretty high, so the better the windows perform, the better the house is going to be.
Raf, now I noticed that there were quite a few outlets on this ceiling here. You've obviously got your recessed lighting, which is a pain in the ass when it comes to air tightness on their own, but you got doubled up outlets on this ceiling. So what are all these?
Littered with holes and vents. Basically, one is the ducted heating system, as you'd see in a lot of homes. The other one is a ventilation system. It was put in as a trial. Where basically, there are a number of companies here in Australia that will draw air from the roof cavity space, which they say is indirectly coming from outside, because if you don't have sarking and so on, it's coming through the tiles. And then it goes through a filter, And they're basically saying you're drawing warmth from the warmer roof cavity, as well as indirectly outdoor air, putting it through a filter and introducing it into the house.
Jeez.
But there's some question marks because the filtration's got to be pretty good. You know, we're going to show what a roof cavity looks like and the quality of the air that's actually coming in from a roof cavity with mice and rats and mold and who knows what else up there.
And changing the filters would be a nightmare, and you wouldn't even think about it most of the time.
Yeah, well, you've got to, there's some companies that are pretty good about it. They'll literally come each year and they will go and change the filters. So they're fairly good about that, some companies. But generally speaking, what we want to do is do away with that and obviously put in a true heat recovery ventilation system that's drawing outdoor air, only putting it through a very good filter system and retaining the heat through that heat exchange from the house and then introducing that. So yeah, be a bit of a difference. But that's what, all these other holes in the roof are.
Using a true heat recovery ventilation system like a Stiebel Eltron system will allow us hopefully to get to where we need to be for NFIT standard as well, which is essentially under 1 ACH, 50 pascals. So our major concern with this house is whether or not that can be done with the combustion heater left in the building. So we're going to kind of test again later in the project once we get to that point.
And the extraction, you know, that was a big debate with us as well. You know, that's another hole in the ceiling.
Yeah.
But from a healthy building point of view, I looked into a lot of reticulated systems and just...
For the range hood you're talking about?
Yeah, for the range hood,
cooking,
literally, there's a lot of grease, there's all this cooking stuff and relying on filters and carbons to keep changing that. And I just think
you want it to go straight out?
I want it to go out, and I realised that's another compromise. But we're all intrigued to see what we can achieve.
We're going to put an inline baffle in the extract there, and we're going to bring a supply air as well, which we will for the combustion heater too, because obviously if the combustion heater stays and we get to those sort of levels of air changes, we're going to have supply air. So we'll do the same with the range hood too, and the supply air will also have a baffle on it. Had some testing done on that which would suggest around 0.04 air changes on a closed loop system for that. So yeah, hopefully that'll work.
It'll easily be one of the only true retrofit volume house building home, that's for sure.
Yeah, we did one a few years ago, but it wasn't a volume builder house. It was just a custom built house. We did all right with that one. We got that to 0.88. So, but that was a different setup. It was on a subfloor. It was a weatherboard house. Here we've got brick veneer on a slab, on a waffle slab. So yeah, it'd be interesting to see how we go.
All right, Dale and Raph, so we better let you guys get stuck into it.
We are back to Torquay to check on the progress of the transformation from a volume builder home to a healthy and energy efficient house. This used to be one of the volume house builder home that we see in any of the capital cities in Australia, and now it is in its transformation, I would say almost in the cocoon state where it is being reformed. So tell us something about what are the challenges you face when trying to convert a common typical volume builder home to a passive house inspired home.
No worries, Joseph, thank you. Obviously it's a much different challenge to a new home because none of the passive house principles or building physics principles have been thought about and integrated into the building from day one. Things like a lot of re-entrant corners, a lot of junction details, eave lines, these things aren't considered and make life a lot more difficult for a retrofit, particularly in this building, a lot of internal wall junctions where we haven't completely removed all the internal walls. We haven't completely taken all plaster off, so we've used the existing framework to our advantage as best we can to create a continuous airtight envelope. We feel like we've done a pretty good job here. The guys have been working tirelessly the last few weeks to just make sure we get on top of every little nook and cranny that air could possibly pass through, and it's all looking pretty good. So we're looking forward to getting a test done today and finding out where it's at. This is obviously a preliminary air tightness test, so we're at the stage where plaster's about to start next week. We've just got to finish internal battens over the next couple of days. Plaster will go in next week, so this is our last opportunity to really put the building through its paces, find out where it's at.
Oh, that sounds good. And you said there's no consideration in the environmental performance or anything. Ralph, When you bought this house, did you know what was the star rating to start with?
Yeah, I don't think there was a star rating as such, because it's sort of 15 years old, and I think the 5-star energy rating came in just after this building was finished. So that's why there was no insulation in the walls when we questioned it. They said, oh no, just as you sort of signed off on it, 5-star energy rating hadn't come into effect. I don't even think it had star ratings. I don't think existed then. We certainly didn't think about it.
Just missed the boat.
Yeah, exactly right. Yeah.
And so Joseph, it had, when we started pulling the building apart, we found that, as Raf said, there was no insulation in the walls. There was an aluminium sarking on the outside of the timber frame, which we've actually removed. Not only is this building about building physics and energy efficiency, thermal comfort, it's also about building biology and making the building as healthy as possible. Raf is a building biologist, so for him it was really important. That was kind of the starting point of this project for Raf, was to make the building as healthy as he possibly could by being introduced to us, and through the discussion of how we achieve that for this building. Raf was introduced to Passive House and higher levels of hygrothermal performance, and so the building just evolved from there. Coming back to the sarking layer, we removed all of that because that was...
It's very conductive because of the foil.
Yeah.
And running cabling through it's not something we like to have in walls.
Yeah, so Raf's really made sure that all the cabling in the building has been done in such a way that it removes as much of the electromagnetic field as possible. All the materials that we have used on the internal envelope of the building are being approved by RAF, so we're sending him all the chemical data sheets to make sure that he's happy with all the chemicals that are in the products and signing off on those. So it's been a really interesting building from that perspective as well. It's a real holistic approach to healthy building, essentially.
Wow. Have you jot down all the notes, getting a cheat sheet for the future house that you can bring it beyond Passive House?
Oh, absolutely, and Raf's documenting the process really thoroughly as we go, and we're certainly learning a lot as we go as well. We were aware of building biology before we started this, but we had no idea to the level that it can be taken. So it's a really good sister approach to Passive House, I suppose, and really just finishes off that level of sustainability, energy efficiency, thermal comfort, and healthy building, essentially.
Yep. Can you take us through a couple key areas that you find that is not performing 100% in the original house when you try to take out the wall? Did you find any moisture issue, water leaks, or anything like that?
Yeah, I think I'll let Raf speak to the windows.
Yeah, the showers were the surprise, that they seem to have held up pretty well, although we did have shower troughs or basins, not tiled, but they seem to be not too bad. We had real issues with the glazing and the framing. Some of the glazing windows weren't even put into the slab. Wow. No fixings in there. And we found a lot of air gaps. I think the biggest thing was when we took off the architrave, we found that you could just see straight to the outside.
Oh, that's very common.
That's very common. I didn't see, I was like, yeah, wow. So when you strip it back, an architrave is all that lies between you and the freezing cold. Yep. We had a number of issues with the fibre cement sheeting that was above all of the windows and glazing. That, of course, was just flimsy nails and glue, and that was all starting to come apart, and water was getting in. A lot of issues on particular windows and forms of glazing where we found, when I was taking moisture readings, I could see it was coming in over there, it was coming in the study. We had to literally go around with caulking as a temporary measure to try and just keep the weather out, that it was coming right through. So that was interesting, that we found. One thing up in the aerial, where the aerial went on, wasn't quite sealed well, so water had gone into that, and there'd a bit of mould on the timber truss.
And you've been testing the moisture content of the slab as well, and there's been certain areas around the building where soil has been backfilled above the damp-proof course, and so moisture's been getting into the freeboard of the slab and migrating back up into the building, and we've had quite high moisture content in certain areas. So Raf's actually been spending the last week digging right around the perimeter of the building to find the old vapor barrier under the slab and bring that up so that it actually comes up to the top of the damp-proof course.
So it is one of the tips or suggestion that we can give to all the renovator and gardeners when you work close to the edge of your home. Be careful, don't let the dirt build up too high.
Absolutely.
So you try to minimize the potential for any moisture ingress from the soil. What are the changes, more obvious changes in this house compared to a conventional build in terms of material selections?
Yeah.
I can tell it looks different, the color from the insulation above the wrap.
Yeah, absolutely. So the beginning of this project was actually taking the existing tile roof off. That was the first job that we undertook. As Raf mentioned, there was some water ingress issues, weather ingress issues in the roof. So we wrapped the whole roof of the building in a weather-tight layer, a permeable weather-tight layer, and then we replaced the roof with ColourBond roof sheets as opposed to roof tile, take some of the weight off the existing roof. And then as we moved into the building, we've replaced what insulation there was in the ceiling, fiberglass insulation that had compacted quite significantly over the years. We replaced all of that with R6 polyester insulation, which has a fairly high component of recycled materials in it. Doesn't seem to condense as much over time, so it holds its form and shape quite well. And that's gone into the walls as well, and we've used a high density insulation in the walls to get a little bit better R value out of the performance of the walls, so they're 2.7 as opposed to 2.5 as a standard. And then as we come further into the building, we've put the air tightness layer in. On this occasion we've used Sigger, and that's what's obviously being tested today and what's created a airtight envelope, internal airtight envelope, moisture barrier to obviously control condensation risk and moisture ingress into the building envelope. And that will obviously be further controlled by the fact that there's a Stiebel Eltron heat recovery ventilation system in this building, which will hopefully ensure that the building stays close to that 20-21 degrees day in, day out, year round, and also controls the relative humidity in the building at the same time.
Yeah, from an air quality point of view, just to add to what Dale said, I think one of the biggest issues here was the amount of dust and rubbish that had got into the roof cavity that blows in because there's no sarking or any membrane of any kind. I was amazed at the amount of mouse and rat, urine and feces, all sorts of disgusting stuff up there, and carcasses themselves. And just the amount of debris and dust, literally as you pull things down, dust goes everywhere. And so just like the air from an energy point of view getting in, from my point of view, when you get stuff from the roof cavity coming in, you're getting on that piece of dust all sorts of things. You're breathing in old fiberglass, which has flame retardants, which has pesticides applied to it, and then you've got all of the pests and their leftovers all up there. So big air quality now. I mean, you could go up there and sleep. I had my kids put the insulation to their face, say, it's scratchy, is it whatever, polyester, like Dale was saying, doesn't support mold growth as much. If that gets wet, it's plastic, so to speak. So from that point of view, we love the polyester. It doesn't break down. The one disadvantage in the environment that it lasts forever, but that's what you want in insulation, that it lasts forever.
The R values. If it is recycled material, it's good enough. You're not bringing extra burden to the environment.
And what you just said then, Joseph, too, is kind of where RAF started with this project as well, essentially recycling and reusing a building. I mean, the majority of Australian building stock already exists. They're building, a lot of them are buildings like this. We actually suggested to RAF when we started, why don't you find a block of land elsewhere and build a new house, because you're going to spend a significant amount of money on getting this building to the level that he wants it to be at. But RAF and the family are obviously very happy in this area, and it was a big thing for RAF to not just get rid of or demolish another house and build a new house or do something different, like use what's already available, use the resources that have already been put into this building and regenerate them and bring them into something at a much higher level,
And apart from the extra cost that we need to spend on all these nice features, what other aspects are we sacrificing to gain the higher performance? Like space-wise, headroom-wise, how much are we sacrificing?
Okay, yeah, so in this building in particular, you're losing about 35 mil in your wall area because you're putting a services cavity in over the top of the air tightness layer. So about 35 mil on the walls. In this case, the ceiling we've reduced by approximately 100 mil just to be able to let us run the ventilation ductwork comfortably within the thermal envelope. Originally, we discussed the idea of running that outside the thermal envelope, which is possible, but it's a lot more work in insulating everything all the ductwork and that, and there's no guarantee that it will perform as well.
Yep.
And there is also a risk there that if any vermin did get in there, that they could essentially get into the ventilation system or something as well. Certainly keeping the ventilation system and ductwork within the thermal envelopes are a really good way, smart thing to do. Bit of a sacrifice on Raf's behalf there. He wasn't too keen initially to reduce the ceiling level because these homes don't have overly high ceilings anyway, but we're still above, I think we're about 70 mil above BCA standard of 2.4 for habitable rooms. So
we were lucky to an extent that when we originally built, we paid extra to raise the ceiling level.
Yep.
So we were at a high level, otherwise we couldn't have lowered it, we couldn't have done this. So that's my biggest sacrifice from my point of view, being taller. The lowest ceiling is the opposite to what I want, but that's been one sacrifice.
And we've managed to work through that a little bit too, in the sense of we've created a trunk that runs down the hallway of the building. So in the living space, we've been able to keep the ceiling at the full height, at the original full height, and just drop the trunk in the living space to run the ductwork. So there's some compromises around things, but we've tried to do it in a way that maintains the aesthetic of the original building and the feel of the original building, but also get the best performance out of the ventilation system.
Excellent. Well, with a ventilation system, you got a cleaner, healthier home. I think you can spend more time comfortably just rolling on the floor, which the low ceiling doesn't affect you as much.
That's right. That's a good point.
No, absolutely. Very, very excited about moving back in. I can't wait.
On the floor, we've changed the floor. Raf's selected a very clean, chemically inert flooring system, as opposed to the original tile floor. So the tile floor was quite cold, obviously. Unfortunately, the one Achilles heel of this project is it is on a slab on ground, which we can't retrospectively insulate unless we were to insulate over the top of the floor, but that just became cost prohibitive in this case, and we don't have any more room essentially. But Raf and Chantal have decided to go to an engineered timber floor, which will hopefully just take a little bit of that cold feeling out of the floor as well. So it is on a waffle pod, so it is insulated to some degree, but unfortunately the freeboard of the slab isn't insulated. So there is that weak point in the building.
And how did you address the common problem like lacking insulation around the lintels and around the window area? Did you do anything special to address that?
Yeah, so the really common approach in buildings like this, brick veneer buildings like this, is that there's always a lightweight infill over the top of windows and doors, which there was in this case, which was a cement sheet. So we removed that cement sheet and we insulated where we could around the lintel, and then we put a layer of timber fibre insulation over the top of that, which is a pre-rendered system, which comes out flush with the existing brick veneer wall. And so this building is being rendered completely on the outside, and that's actually providing a watertight seal to the brickwork as well. So yeah, we've insulated over the top of all lintels now and around lintels as best we possibly can. There are some small weak points like T-junctions of internal walls into external walls where we haven't been able to get right in there behind to fully insulate, but there's only 2 or 3 of those through the building as thermal bridges, unfortunately. But again, like the slab, there's only so far you can go with an existing building, but it's going to be significantly better. I mean, you can already feel it in the building that is significantly better.
What about the very common issue with volume builder home, the missing insulation around the full edge around the whole building? How did you address that?
Yeah, so when we had the roof off, we actually went through and put a bridging piece in all the way around the perimeter, so it sits over the top of the cavity wall essentially, and that was a high density insulation to give us a higher R value, because you've obviously only got a fairly small cavity there. So we've done that as well, and then we've run the R6 insulation as best we can up to that point, so there's a crossover in the junction there.
Excellent. So before we do the air tightness test, where are the areas that you're most concerned about?
It's always a little bit of a concern wherever there's a penetration. So wherever you've got services coming through the building, you'll be able to see as we walk around that we've taped up all electrical points, and there is still a split system in this building, an existing split system which has been taped up. The ventilation system is always one because you've got quite big penetrations for the internal and external air on that unit.
But what is particularly for this building, because it's a retrofit?
Yeah, it'd probably be the junctions of the internal walls with the external walls, to be honest. We've actually used the stud there in that T junction as an air tightness barrier. So we've taped everything to that, and then we've Orcon or silicon any penetrations through that T junction. So that's probably the biggest one, and maybe some of the penetrations for the bath or the shower wastes and areas where they've penetrated the slab as well. So, but they've all been taped up and sealed as best we possibly can too.
Yep.
So, yeah, it's definitely, it's much more difficult thing to do, but a retrofit as opposed to a new build. But in saying that, because we know it's so much more difficult, you spend a lot more time and you're a lot more diligent with it. So hopefully we've found any issues, really.
How confident are you?
Pretty confident, yeah. I'm confident that it'll be under one air change, which is a retrofit standard for Passive House. I think if I was to guess, I'd say it's probably around 0.8, 0.9, somewhere like that. And that's based on previous retrofits we've done. Yeah, I'm not overly confident that it'll be under 0.6, which is the new Passive House standard.
How much would you bet on the beer fund?
I don't know. It's I don't think I'll bet any of our progress claims on it, that's for sure.
Okay, let's get to the moment of truth.
Absolutely. Let's do the testing.
Yep. When installing internal wraps, it's all about care and attention to details. Just look at this installation. You can see, even when you see the overlapping, can you see the white line is going along nicely, so straight across, and you can see the installer is putting a lot of effort and attention when he's installing it. And when you look at how nice and straight all the tapings are and how minimalist it is, you know they know what they are doing. The other major difference when you need to install a internal air barrier above the ceiling is usually when you install the insulation, you need to put some straps, what you can see, the blue line, to hold the insulation above, and then you can install the wraps. That way, the insulation won't putting in any extra force on the membranes, and that can maintain the integrity and holding the membrane in place a lot better. Internal cavity slider, it usually causes a lot of trouble and a lot of air leaks in common homes. But for this one, they won't have the problem, because when we look up, the internal airtight membrane going above through past the cavity wall. So there's no connection from this door to any external air. The floor is sealed with the slab, the roof is cut off with the membrane, and it's not connected to the external wall, so it would cause you no trouble at all. Wow. 0.5.
0.5, Joseph, that's incredible, isn't it?
Well, it's better than a brand new Passive House.
Yeah, I mean, you couldn't ask for any more, really. It would meet the new standard for Passive House.
Yep.
Actually, quite surprised. I didn't think it would be that good, to be honest. So
why don't you have trust in your boys?
No, the guys are terrific, and they're getting better and better with each project, and it's just amazing how good they are at this now and how much they love doing it. All congratulations go. I only put about 3 pieces of tape on this whole house myself personally, actually. So our guys did the majority of the work.
What I can say, looking at this house, all the tapes on the membrane compared to most other houses that I've seen, it comes back to less is more.
Yeah, absolutely.
Use the least amount of tape to get the job done, always get you a better result.
Absolutely. And what we've learnt too is using the double-sided tapes as opposed to staples or nails or screws or whatever. Like you really just eliminating penetrations in the envelope is so important.
Yeah, staples sometimes is killed by 1,000 cuts.
Yeah, exactly. That's right. Yeah, we learnt that the hard way years ago when we did one, and we put a lot of staples in, and it just missed out on the 0.6 at that time, and I think it was mostly the staples. So yeah, but it's interesting here to note that the junctions, the way we've done the studs, and those internal external wall junctions, are actually performed really well. So yeah, it was interesting to know. So got to be pretty happy with that, Raf. You at least pretty confident that your indoor air quality is going to be completely controlled by your HRV and by your interaction with the building.
Yeah, absolutely. Yeah, I wasn't expecting a result like that either.
Just need to remember to replace the filter.
Yeah, that's it. Yeah.
Exactly. No, we'll definitely remember that. We'll be all over that. Yeah, just incredibly happy. Your guys have all done and got this result.
Yeah, thanks, Raf.
Fantastic.
Cheers.
Great job.
Yeah, we couldn't be happier. It's
excellent.
Great.
Now is the biggest challenge to keep it intact in the next phase.
That's right. We got the plasterers coming next. It can be a little bit hard to keep a hold of sometimes. So
plasterer, all the other trays.
Yeah.
Keep an eye on them, and we'll come back again and do the final test.
Oh, I can't wait. The family's hanging. I just said I won't spend another winter in this building as it was because of all the condensation, freezing cold, dust, whatever. So to see it that it's going to perform like this, most people say they want to move in by Christmas. I'm really excited to move in for winter because I want to see middle of winter how it performs. That's when we'll be moving in.